Hello everyone, welcome back to my channel. So in this video we'll be discussing the complete linear programming chapter in one shot. So we'll be discussing the following topics. At the very first we'll discuss what is bounded region, then the non-feasible region, and then we'll discuss the unbounded region. And in the last we will even solve some important examples that are very important from the CBSE point of view, the board exam point of view. So let's start. Now let us first start with the bounded region problems. So this is our first example on bounded region. So here they have asked us to solve the linear program graphically, and they have given us maximize this. So first of all, this maximize or minimize, this thing is called as the objective function. Okay, so this one is called as an objective function. They can even give you minimize in place of this. Okay, minimize or maximize. So this is our objective function. Then subject to this are the constraints. Okay, they are known as the constraints. So we have to take the constraints and we have to graph. Okay, so first of all, the constraint which you can see over here, this x comma y is greater than equal to 0. This is only for the check of quadrant. Like over here you can see they have given us that x and y are greater than equal to 0, which means they are positive. And if they are positive, which means that they lie in the first quadrant. Okay, this is our this are four quadrants, first, second, third and fourth. So x and y greater than 0, which means they lie in our first quadrant. Okay, that is that information for, and rest of these two constraints we have to take them and we have to graph. So first let us write them. X plus 2y is less than equal to 10 and 3x plus y is less than equal to 15. So these are our two different constraints. So in order to plot them, we have to find the different points so that we can use to plot these kind of constraints. So first let me write this in the form of an equation, and then I'll find the points so that I can use them and plot the graph. So I can write this as x plus 2y is equal to 10. Okay, now I made it as an equation. Okay, I'm considering it as an equation. Now I'm going to take the points. Just like how we do in our normal graphs, I'm going to take the points. Okay, x, y. So now if in place of x I put 0, then my y turns out to be 5. And in place of y, if I put 0, my x will turn out to be 10. Okay, according to this equation I'm saying. Right? So these are the points that I'm going to use to plot this line, this constraint. And then I'm going to check for the second one. So this one also I can write it as an equation like 3x plus y is equal to 15. Okay, so 3x plus y is equal to 15. I took an equation. Now I'm going to find the points. So whenever you find the points, you always check for 0 first because it will give you smaller values. So when I put 0 in place of x, I'll get y as 15. Okay, and when I put 0 in place of y, I get x as 5. So these are my points that I got for both of the equations. I'm going to take them and plot the graph. Okay, and then I'll check for the feasible region. So first let us plot the graph and see. So here comes our graph for the question. So I've already plotted the graph. So our two equations were these two. Now when we plot the graph, if you check, first let's check this equation. So the points were 0 and 5 and 10 comma 0. Okay, so 0 comma 5. So where is this point 0 comma 5? It is over here. Okay, so that is our point 0 comma 5, and then the other point is 10 comma 0. So 10 comma 0 is over here. So these are my 2 points, and now I'm going to join a line, draw a line joining these 2 points. Okay, so this is what I've drawn over here. So that is the line. Now whether this line should be a straight line or a dotted line, it depends upon the inequality sign. Okay, suppose you have this sign that greater than equal, less than equal to, or greater than equal to. When you have got this equal to symbol, then you're going to draw a straight line. But if you have only greater than or only less than, then you're going to draw a dotted line. Okay, like in this case, if you see this equation which was there, that is the inequality which was there, which we plotted, in that case we had less than or equal to symbol. So there was an equal to also with that less than. So that is why we drew this straight line, that is a normal line. But if there was only this symbol without this equal to part, if there was only this part, then we had to draw a dotted line. Okay, so that is the difference. So in this case, since we have got less than and equal to, so we'll draw a normal straight line instead of a dotted line. So that is what we have drawn over here. So we plotted our first inequality. Now we will plot our second inequality, that is 3x plus y, which is equal to 15, this one. So the points are 0 and 15, that is 0 comma 15. Okay, so we don't have the place for 15 over here. So let me take a point which comes within 10, okay, for this equation. So let me take my x as 2, okay, you can take any random points also. So let me take my x as 2. Now when I take this x as 2, what will you get for y? Okay, now if you substitute, if I take x as 2, 3x plus y is equal to 15, then if you solve this, you get your y as 9. Okay, so the other point, let me take it as 2 comma 9, so that it fits in this graph. Okay, so the other point is 2 comma 9. So if you check, 2 comma 9 is over here. Okay, 2 comma 9, this point lies over here, and the other point is 5 comma 0. So 5 comma 0 lies over here. So now we are going to join this line, that is what you can see here, this line we have joined. Okay, we are going to join those 2 points by this line. So this becomes the line of our second inequality, that is 3x plus y, which is less than equal to 15. So since there is a symbol of equal to with this less than, you can see over here, that is why we have drawn a straight line instead of a dotted line. Okay, so here is our second step done, that is we have plotted the inequalities. Now the next step is to check for the feasible region. Okay, so when we check for the feasible region, we have to take a point and check the feasible region. Like suppose over here we'll take 0 comma 0, okay, and we'll check for the feasibility, that is which side we should shade. Right, now we'll take both the inequalities and we'll check which side we have to shade. Okay, so the first inequality, first we'll take 3x plus y, which is less than equal to 15. Now we will check its feasibility for the point 0 comma 0, which means I'm going to substitute this 0 comma 0 in place of x and y in this inequality. So when I substitute, it becomes 0 plus 0 less than equal to 15, that is 0 is less than or equal to 15. So if you check here, 0 is less than 15, right? So this becomes true, this inequality is true. Now you can see here, this is 0 is less than or equal to 15. So since it is less than 15, this inequality is true. So when it is true, this shading will be done towards that point 0 comma 0. So if this would have been false, suppose if this thing would have been like this, that suppose if the inequality would have been greater than equal to 15, and you would have got something like this, that is 0 is greater than or equal to 15. So in this case you can see that this is clearly false, because 0 is not greater than 15, neither is it equal to 15. So it is false in both the cases. So if in such a case, if you find a false statement or a false inequality, then in that case you have to shade it away from that point, that is away from 0 comma 0. Okay, this is the point 0 comma 0. So if the statement comes true, then you will shade towards the 0 comma 0, and if it comes false, then you will shade away from 0 comma 0. Okay, that is in the opposite direction. So in this case, since it is true, since 0 is less than 15 and the statement is true, so we are shading towards 0 comma 0. Okay, that is this side, or the side which I am indicating by the arrow. Now we will take our next inequality, that is x plus 2y is less than or equal to 10. Okay, and then again, so for you have again I'm going to take the same point 0 comma 0 and check for its feasibility. So you can take any point. Suppose if I take here 2 comma 2 also, suppose if I take this point and if I check the feasibility, and if the statement comes true, then you would have shaded towards that point, and if the statement comes false, then you would have shaded away from that point. Okay, so that is how you check. So here in this case I'm taking 0 comma 0 as that point. So when I substitute 0 comma 0 in place of this x and y, I get 0 plus 0 is less than equal to 10, that is 0 is less than equal to 10. So if you check 0 is less than 10, that is this inequality is true. Okay, it is true. So when it is true, I will shade towards 0. okay, 0 comma 0, that point. So my line for this one is this one. So I will shade towards 0 comma 0, that is I'll shade this side, okay, I'll shade this side completely. Okay, so I checked for my feasibility. Now when I shade both of these sides, when I shade this part also and when I shade this part also, when I shade both the parts, when I check this blue part which you can see over here, this blue part is my common region, okay. So when I shade for both the lines, this blue part comes as my common region. So this is my feasible region, that is this blue part. And if you can see, this is called as a bounded region, okay. It is called as a bounded region. Now if in case it was false, and if it in case it comes something like this, okay, these are my two lines, suppose, like in this case it is like this, okay, it is bounded region. But if in case it's something like this, okay, if that statements are false and if you have to shade towards this side, then this becomes an unbounded region, okay. You can see it is not bounded by any lines, it's just going. So this is an unbounded region, but here this one is unbounded, okay. This is an unbounded region, but in this example which we have taken, we got a bounded region. So here comes our bounded region. So we have checked for the feasibility. Now our next step is to write the corner points and find the value of z. So if you can see, I've already got 3 of my corner points, that is 0 comma 0, 5 comma 0, then this 0 comma 5, and this b part, that is 4 comma 3. Now you must be wondering how I got this b, that is 4 comma 3. So so for finding that point, basically what you have to do is you have to take those two equations, that is here I have to take this equation x plus 2y and 3x plus y is equal to 15, and I have to solve both the equations. You can solve it either by elimination method or substitution method, and whatever the value of x and y you get, that is your intersection point of two lines. So if you can see, this b point is the intersection point of these two lines, which means that it is the solution of those two lines. So when you solve these two equations, that is x plus 2y is equal to 10 and 3x plus y is equal to 15, when you solve both of them, you get x as 4 and y as 3. So that is what is your intersection point, and that is how I got this point P. Okay, so now we have found the corner points. Now since you can see the question over here, this is the z equation. So after finding the corner points, we have to find the value of z, and then we have to maximize it, okay. Maximize in the sense we have to find the maximum value of z. So let us see. Now I've made a list of all the corner points that we have found from the graph. You can see these are the points A, B, C and D. These were the corner points, okay. Now in this graph we took these 4 corner points. So these corner points I'm taking. Now I'm going to find the value of z. In the sense, I'll take these corner points, that is the value of this x and y, and then I'm going to substitute in this equation of z and then get the value of z, okay. It is as simple as that. So like for the first one, if you see, z is equal to 3x plus 2y. So in place of x, I'll substitute this 0, and in place of y, I'll substitute this 5. 2, 5. Now when I solve this, I get the value as 10. So this is how I'm going to find the value of z. Similarly for the second one also, z is equal to 3x plus 2y. So in place of x, I'm going to substitute this 4, and in place of y, I'm going to substitute this 3. So that is how I get the value of z, which is equal to 18. So similarly for the other two values also. So we get these two answers for the other two values by substituting those values of x and y in this equation of z. So now we got our value of z from these corner points. Now in the question they asked us to maximize z. Maximize z in the sense we have to find the maximum value of z. Now if you check in these 4, that is in 10, 18, 15 and 0, if you check for the maximum value, 18 is the maximum value over here. 18 is the maximum value. So we found our maximum value, which means that we got our answer. So we are going to write our conclusion point, that is z is equal to 18 is maximum. Now it is maximum at which point? If you see, it is maximum at point P, that is 4.4, 3. So it is maximum at 4, 3. So that is how we solve this kind of questions for the bounded region. Now just in case, instead of this maximize, they would have given minimize in place of this maximum. Just in case, if they have given minimize in place of maximize, then you have to find the minimum value of z. Now if you check over here, the minimum value of z is 0. This is the minimum value of z. So if they would have given minimize that z, then you would have written z is equal to 0 is minimum at 0 comma 0. So that is how you solve these kind of these kind of questions for the bounded region problems. Now we solve a bounded region problem. Now let us see an example for not feasible also. So in this case, you can see they have asked us to minimize. So this one is our objective function and these three are our constraints. Okay, so the first step is to find for the points, and then we are going to plot them. So let us write our inequalities. Our first inequality, that is x plus y, is greater than equal to 8, and the second one is 3x plus 5y is less than equal to 15. So first step is to find for the points. Okay, so now if I substitute 0 in place of x, I'll get the value of y as 8. Okay, now if you're finding confusion, you can write this as x plus y is equal to 8, and this one as 3x plus 5y is equal to 15. Okay, write it as equation and then you can find the points. So when I substitute x as 0, I get y as 8, and when I substitute y equal to 0, when I substitute 0 in place of y, I will get x is equal to 8. So I got the points for my first inequality. Now let us see for the second one, that is 3x plus 5y is equal to 15. So when I put x is equal to 0, that is when I put 0 in place of x, I get 5y is equal to 15, which means that my y is 3. Okay, similarly if I put 0 in place of y, I get 3x is equal to 15, which means that my x is equal to 5. So I found the points, and now I'm going to plot the graph. Now let us plot the points. So now let us first see this one, x plus y is greater than equal to 8, that one. So the first point will be 0 comma 8 and then 8 comma 0. So search for 0 comma 8. 0 comma 8 will come over here. Okay, and 8 comma 0 will be this. Okay, so as you can see, we have drawn a line joining these 2 points, and that is the line of this inequality x plus y greater than equal to 8. Now as you can see, with this greater than symbol, there is an equal to also, that is it is greater than or equal to, which means that we have to draw a straight line and not a dotted line. Okay, that is why we have drawn a straight line over here. So we plotted our first inequality. Then for the second one, that is 3x plus 5y less than equal to 15, again you can see here there's an equal to symbol with this, which means that we are going to draw a straight line and not a dotted line. So we are going to plot the points 0 comma 3 and 5 comma 0. So this is the point 0 comma 3 and this is the point 5 comma 0. So now as you can see, we have drawn a line joining these 2 points, and that is the line of the inequality 3x plus 5y less than or equal to 15. So we have plotted these 2 inequalities, and now we are going to check for the feasible region. Okay, so just like how we did for the previous sum, we'll take this point 0 comma 0 into consideration, and we will check for the feasible region. Now let me first check for this 3x plus 5y less than or equal to 15. Okay, let me first check for that one. So when I check at 0 comma 0, when I check for its feasibility, I'm going to substitute this x as 0 and y as 0 in this inequality. So when I substitute both x and y as 0, I get 0 is less than or equal to 15. Now if you see here, 0 is less than 15, which means that this is true. Okay, so 0 is less than 15, so it either should be 0 equal to 15 or 0 less than 15. So since one of them is true, we are going to shade it towards 0. Okay, we are going to shade it towards this part. Okay, towards 0. If it would have been false, then we had to shade it away from that point, that is away from 0. But since it is true, we are going to shade it towards that point 0 comma 0. Okay, so that is how we have shaded this blue color region over here. Now let us check for the second inequality, that is x plus y greater than or equal to 8, and here also we'll check for this point 0 comma 0 only. Okay, so when I substitute x as 0 and y as 0, I get the answer as 0 is greater than or equal to 8. So neither is 0 equal to 8 nor is it greater than 8, which means that this is false. This inequality is false. Okay, so 0, since it is not greater than 8 or it is not equal to 8, which means that it is false. That is, instead of shading towards 0, we are going to shade it away from 0. Okay, that is away from this point 0 comma 0. So since we are shaded away from that point 0 comma 0, as you can see this blue color part, we have shaded it away from that point 0 comma 0. Now in the last, if you check for the feasible region is nothing but the intersection part. Okay, that is the region where both the shaded regions intersect. Now if you can see here, the shaded regions are not intersecting at any point, which means that this is not feasible. Okay, so since there is no common shaded region between these two, we can see that it is not feasible. So for the conclusion point, you can write that as there is no common region, okay, as there is no common region, so there is no feasible region. Okay, so since there is no common region, there is no feasible region only. So how are we going to find the corner points, and then how are we going to find the maximum or the minimum value of z? So since there is no common region, there is no feasible region, which means that there is no minimum value of z. Okay, so in our question we were supposed to minimize this z, that is our objective function, but since you didn't find any common feasible region only, which means that there will be no corner points, so we cannot find any minimum value of z. Okay, there will be no existence of any minimum value of z. So this was an example of a non-feasible region. Now let us see an example of unbounded region. Now let us solve an example of an unbounded region. So in this case, they have asked us to minimize this objective function, and these are our constraints. So first step is to find the points that we are going to plot in the graph. So our constraints are 2x plus y greater than equal to 3 and x plus 2y greater than equal to 6. Okay, so these two are our constraints, and now we are going to write them in the form of equations, and we are going to find the points to plot the graphs. So let me write this as 2x plus y equal to 3 and this one as x plus 2y equal to 6. Now for this first one, if I put x as 0, then my y value will be equal to 3, and suppose if I put y as 0, then I'll get a fraction. So to avoid this kind of fractions, see, if I put y as 0 in this, 2x plus y is equal to 3. If I put y as 0, I'll get 2x is equal to 3, that is x is equal to 3 by 2. So I'll get a fraction. So in order to avoid these kind of fractions in the graph, let me check a value which will give a whole number. So suppose if I put my y as 1, then I'll get my x as 1. Okay, see, suppose if I'm placing y 1 in place of y, I get 2x plus 1 is equal to 3, that is 2x is equal to, this goes over there, 2x is equal to 2, which means that x is also equal to 1. So when I take x as when I take y as 1, I'll get x is also 1. So we have to try to avoid this kind of fractions also, so that it will be easier to plot the points on the graph. Okay, now for this next inequality, if I take x as 0, I'll get my y as 3, and if I take y as 0, I'll get my x as 6. So now we have found the points, and now we are going to plot these points. So I'm going to take these points and now plot the graph. So for the first inequality, the points are 0, 3 and 1, 1. So here 0, 3 is this point, and 1, 1 is over here. Okay, now when I join these 2 points, I get the line for this inequality, that is 2x plus y is greater than equal to 3. Now since again there is this equal to symbol with this greater than, which means that I'm going to draw a straight line and not a dotted line. Okay, so that is also very important, because if you draw a dotted line, then your marks will be deducted. Now for this second one, um, now the points are 0 and 3 and 6 and 0. So 0 comma 3 again the same point, and 6 comma 0 is over here. Now when I draw the line for this joining these 2 points, I get the line for the inequality x plus 2y greater than equal to 6. Okay, so now that I have plotted these 2 inequalities, now I'm going to check for the feasible region. Okay, so just I'm going to take the point 0 comma 0 and check for the feasibility. So my first one, let me take this equation as 2x plus y is greater than equal to 3. Now this is my first equation. Now I'm going to check its feasibility. Now I'll take the point 0 comma 0, and in place of x and y I'm going to place this 0. So it becomes 0 plus 0 is greater than equal to 3, which means that 0 is greater than equal to 3. Now neither is 0 equal to 3 nor is it greater than 3. Right, so none of the cases is true over here, so this becomes false. Okay, it becomes false. Now since it is false, as you can see for this inequality it was false, so I'm going to shade this region away from that point 0 comma 0, that is this point 0 comma 0. I'm going to shade it away from that point. Okay, since that statement, that inequality has come false. Now if I check for the second one, that is x plus 2y greater than equal to 6, if I check this point 0 comma 0 for this inequality, this becomes 0 plus 0 greater than equal to 6, that is 0 is greater than equal to 6. Now this again is false, because 0 is not greater than equal to 6, it is not equal to 6 also, so it is false at the end. Now since it is again false, the second statement also, so the second one also I'll shade it away from the point 0 comma 0 and not towards it, because it is false. I'm going to shade it away from that point 0 comma 0. So when I shade both of these regions, I get this blue part, which you can see on the screen. This blue part is the common region between these two. Okay, so in this case I got a common region, but the problem here is that my common region is unbounded. Okay, you can see there is no boundaries, it keeps on moving. Okay, it keeps on going and going. So we have got an unbounded region, so we have to further solve it. So my next step will be, I'll take the corner points and then I'll find the value of z. Okay, so if you can see here, the corner points over here are this 0 comma 3 and 6 comma 0. So I'm going to write this point 0 comma 3 and 6 comma 0. Now I'm going to find the value of z. Now let us see what the equation for z was. So z here is x plus 2y. Z is x plus 2y. Now for the first point, that is 0 comma 3, if I put x as 0 and y as 3, I get the value as 6. So here my value of z is 6. Now for the second one, z is equal to x plus 2y. If I put x as 6 and y as 0, I get again the value of z is 6. Okay, so I've got the same value for both of the corner points. Now what I was supposed to do is I had to minimize. Okay, I had to minimize z. That means I have to find the minimum value. Now if you can see here, both the values are the same. That means both of them are minimum over here. Okay, both of them are minimum. So in this case we got 6 as the minimum value. But the problem here is that the graph that we got is of an unbounded region. So in this case 6 may or may not be the minimum value of z. So we have to check for that. Since it is an unbounded region, we have to do one extra step over here. Okay, so till here all the steps were same as that of bounded region, but since in this case it is an unbounded region, so we have to do one extra step and we have to further check that if 6 is the minimum value of z, or if there is any other value which can be minimum, which can be less than 6 also. Okay, so we're going to plot one more inequality over here in this graph. So now we have to write the statement. This statement is very important. We have to write that since the region that is feasible over here is unbounded, so 6 may or may not be the minimum value of z. So for that we have to further graph the inequality, one more inequality which we have to graph. Now which inequality do we have to graph over here comes the question. So as you can see, now here what was my objective function? So in case of this unbounded regions, you have to check for your objective function. Now my objective function was z is equal to x plus 2y. Okay, now this z is equal to x plus 2y was my objective function over here. So now since I am checking for a value that can further be less than 6. Okay, 6 I got as the minimum value, but I have to check whether there is any other value that exists which is even less than 6, that is even more minimum. So for that I'll plot the inequality x plus 2y. Okay, for this you have to take this objective function 1. So x plus 2y less than 6. So I'm checking for a value which is further less than 6 or not. So if in case in the question they would have given us maximize, if in case in place of this minimize they would have given us maximize, then we would have written x plus 2y greater than 6. Okay, now we wrote x plus 2y less than 6 because we are finding for a further minimum value. But if they would have given us maximize, then we would have to find a further maximum value. Okay, so in that case we had to find x plus 2y greater than 6. Alright, so now we are going to plot the this inequality x plus 2y less than 6 on the graph. So for that, first of all let us find the points. Now let us take this as x plus 2y is equal to 6. Let us consider this as an equation, x plus 2y is equal to 6. Now if I put x as 0 over here, then I get my value of y as 3. And if I put my y as 0, then my value of x comes out to be 6. Now I'm going to take these points and I'm going to plot it on that same graph. Now this was the same graph which we had plotted a few minutes ago. So on this graph, now we are going to plot this another inequality, since this is a unbounded region. So I'm going to take this points 0, 3 and 6, 0, and I'm going to plot this graph. So when I take this 0, 3, this is the point 0, 3 and 6, 0. So here is my 6, 0. Now I'm going to draw a line joining these 2 points. Now if you can see here, there is only this less than equal to less than symbol over here, and it is not less than or equal to. So since there is only less than symbol, I'm going to draw a dotted line. Okay, if there would have been an equal to symbol, I would have drawn a straight line, but since there is no equal to symbol, I'm going to draw a dotted line or towards between those 2 points. Okay, because that is not included. So I'm going to draw a dotted line over here. Now I have drawn a dotted line, I've plotted the inequality, and this dotted line is the inequality x plus 2y less than 6. Okay, so this is my third inequality. Now I'm going to check for its feasible region. So now I'm going to take this value 0, 0 like I did in my previous cases, and I'm going to check for the feasibility. So when I take this graph x plus 2y less than 6, and when I check for this point 0, 0, that is when I place this value of x and y as 0, I get 0 plus 0 less than 6, that is 0 is less than 6. Now since 0 is actually less than 6, which means that this case is true. Okay, it is true because 0 is less than 6, right? So this case is true. Now when it is true, you have to shade towards that point 0, 0. So I'm going to shade it towards this point 0, 0. That means I'm going to shade this region. So as you can see, I have shaded my region. If it would have been 0 greater than 6, if the statement would have been false, then I had to shade it away from that point 0, 0. But since this statement is true, I'm going to shade it towards that point 0, 0. Now I got my shaded region over here. Now my next step is to check for a common feasible region between this blue region and this red part. Now if you check here, this blue and this red part has got no common region between them. Okay, there is this intersection points, but there is no common shaded region between them, which means that, and I'm going to write the statements which are very important right now, so just pay attention. So I'm going to so I've written these two statements, so they're very important. Now the statement says that there is no common point, there is no common shaded region between our feasible region and our inequality. Which inequality? This inequality, that is x plus 2y less than 6, which we plotted just now. So there is no common point between our feasible region and our inequality. So we can say that our before answer was only our final answer, that is z is equal to 6 is minimum on all points joining the line 0, 3 and 6, 0. Okay, these 2 points 0, 3 and 6, 0, that is z will be equal to 6, and that 6 only is our minimum value, and that will be minimum at all the points joining these two at all the points on this line. That is, you can see this line joining the points a and b. so this line which is over here, z will be minimum at all the points on that line. Okay, that means that z is equal to 6 is minimum on x plus 2y equal to 6. Okay, so this is our final answer. So that is how we solve our unbounded region problems. So it was similar to our bounded region only. It's just that when we got this unbounded part, we had to again do one further step. We had to take this objective function and we have to further check for more minimum value of less than 6. Okay, if there's further any minimum value, that is why we plotted less than 6. Okay, if they would have asked it for maximum value, then we would have plotted x plus 2y greater than 6. So we took this inequality, we plotted the graph, we checked for the common region, but since there is no common region, so our previous answer only is our final answer. That is, z is equal to 6 only is our minimum value. Okay, so that was an example of an unbounded region. Now let us solve an example, and these kind of questions have very high probability of coming in our final exams. So now let us see what the question says. So it says that one kind of a cake requires 200 gram flour and 25 gram of fat, and there is another kind of cake which further requires 100 gram of flour and 50 gram of fat. So here we have to find the maximum number of cakes. Okay, so for these kind of questions, you yourself have to make your objective function and you have to make the inequalities on your own, and then you have to plot the graphs. Okay, so as you can see now, in this kind of questions you have to identify what you have to do. So since they have asked us to find the maximum number of cakes, which means that our objective function, in that we have to maximize z. If they would have asked us to find the minimum number of cakes, which means we had to minimize z. So in this case we have to find the maximum number of cakes which can be made from 5 kg of flour and 1 kg of fat. So in total they have given us 5 kg of flour and 1 kg of fat, and they have asked us to find the maximum number of cakes that can be made from this much amount of item. Okay, assuming that there is no shortage of any other ingredients used in making the cakes. Now our first step in this would be we have to identify the two unknown quantities that we have to find here. Okay, and we have to take them as x and y, and then we will find the inequalities, and then we will find our objective function. Okay, so first step is to find the two unknown quantities, or the two major quantities that we are referring over here is. So we are talking basically we are supposed to find the number of cakes. Okay, so that is our unknown quantity over here. So what are the two different types of cakes? There is one kind of cake and another kind of cake. So there are two different kinds of cakes. We will take the first kind as x and the second kind as y. Okay, so let me write the statements. Let number of cakes of first kind be x and number of cakes of second kind be y. Okay, so we took our two kinds, that is two different kinds of cakes, that is our two different unknown quantities. One was the first kind of cake, that is we took as x, and the other one, that is the second kind of cake, we took as y. So these two are our unknown quantities over here. Now we will make a table and we will put in all the values over there, and now we will make the inequalities. Okay, now let me make the table first. So now we will tabulate all the values in this table. So now we got our the two kinds of cakes. Now we took the first kind of cake to be x. Okay, the number of cakes of first kind we took as x, and the number of cakes of second kind we took as y. Okay, now what are the two different values that we are referring to along with these cakes? Now we are referring to flour and fat. Okay, and their values are further given. So the next two columns will be flour and fat. Okay, so these are our next two columns. Now we have to check for the values according to them. Now as you can see, they have written here that one kind of cake, that is the first kind, it requires 200 gram of flour and 25 gram of fat. So the first kind of cake, that is the first row, it requires 200 gram of flour and 25 gram of fat. Okay, so this full row is for the first kind. Now we are going to check, we are going to fill the values for the second kind, that is the second row. So they have said another kind of cake, that is the second kind of cake, will require this much gram of flour and this much gram of fat, that is 100 gram and 50 gram. Okay, so we got the values for our first kind of cake and second kind of cake. Now further they are asking us to find the maximum number of cakes. So they are asking us to find the maximum number of cakes in the sense that can be made from 5 kg of flour and 1 kg of fat. Okay, so when they have given us 5 kg of flour and 1 kg of fat, it means that in total there are 5 kg of flour, and from that total 5 kg of flour we have to make those many number of cakes, and we have to find how many number of cakes that we are making. So 5 kg of flour is the total flour that is given to us, and from that we have to make so and so number of cakes, that is x and y number of cakes. So 5 kg means we'll take it as 5000 grams, and then total 1 kg of fat is present, that is 1000 grams, and from this much quantity in total we have to make the number of cakes. Okay, so we have to find the maximum number of cakes. So total number of cakes that we have to make will be x plus y, right? Because x is the cakes of one kind and y is the cake of another kind. So in total, when you add both the kinds, in total you have to make x plus y number of cakes. Okay, of in total, like joining both the kinds of cakes. So this is our data over here. Now from this data we have to write our inequalities. So first we will write our objective function. So since I told you that we have to maximize z because they have given us find the maximum number of cakes. So we are going to maximize z, and since we are supposed to find the maximum number of cakes, so total number of cakes that we can form over that we have to make over here is x plus y. X plus y will be the total number of cakes that we are going to make. So our objective function is maximize z is equal to x plus 5. So we got our objective function. Now we are going to find our two constraints. Now our next step is to check for the constraints. So this column will give us our first constraint, and this will give us a second constraint. So as you can see here, 5000 grams is the total gram of flour that is given to us, from which 200 gram we are going to use for x number of cakes, and 100 gram we are going to use for y number of cakes. Okay, so we are going to plot it as 200x, okay, because 200 grams is used for those x cakes, plus 100 y, okay, because 100 gram of flour is used for those y cakes. Now that is 5000. Now here comes the main question, whether I have to put this less than or equal to symbol or greater than or equal to symbol. Now one thing which is important over here is that in the question they gave us that there is no shortage of ingredients. Okay, so here the total flour which is present, which is given to us, is 5000 grams, and there will be no shortage of those 5000 grams of flour, which means that the 5000 grams is present in excess, that is, it is present more than our requirement. Okay, which means that this 5000 grams is definitely more than what we need. Okay, this is how much we need to make the cakes, and those 5000 grams can be either more than what we need, or it can be equal to the exact requirement of what we need. It will not be less than, okay, this 5000 grams will not be less than our requirement, because they have said us that there can be no shortage of those ingredients. So either that ingredient can be equal to our requirement, or it can be more than our requirement, but no shortage. So that is why we have taken that this much is our requirement, 200x plus 100y. This is our requirement of flour, and this requirement is either less than to our total supply of flour, that is total 5000 kg of flour, or it will be either equal to the total 5000 kg of flour, but it cannot be, our requirement cannot be more than the ingredients that is present over there. So that is our first constraint. Similarly, we are going to plot our second constraint, that is 25x, this one, 25x plus 50y. This will also be less than or equal to 1000 kg, because our total requirement for fat will either be equal to those 1000 kg, or it will be less than that total amount of 1000 kg of fat which is present to us. Okay, because there can be no shortage of ingredients. So we got here our two constraints, and the final one, that is x comma y is greater than equal to 0, like how we used to write in our previous sums. Now this is also important because x here you can know that x is the number of cakes and y is also the number of cakes, and the number of cakes cannot be less than 0, right? So they'll always be greater than 0. So we got the constraints over here, and now we got the objective function also. So now we are going to plot the graph just like how we did in our previous sums, and we'll get the answer for the question. So now let me take these two inequalities, that is 200x plus 100y is less than equal to 5000, and the other one is 25x plus 50y is less than equal to 1000. So these are two inequalities. Now we are going to plot the graph, but as you can see the values are really big, so let me just simplify them. Okay, I can remove these zeros. I can make it 2x plus y less than or equal to 50. Okay, if I divide the whole equation by 100, that is the whole inequality by 100, I get 2x plus y is less than equal to 50. Just to remove those zeros, okay, just to make it a little bit less. Now this one also I can simplify. I can make it x plus 2y is less than equal to 40. Okay, like if I divide the whole this thing by 25, okay, if I divide by 100 this one, and this one if I divide by 25, I'm going to get x plus 2y less than equal to 40. So that is how I got my two constraints in more simpler form, and now I'm going to plot them. Okay, so as usual how we did. So we are going to find the points. Now I'm going to write this inequality in form of 2x plus y is equal to 50 like an equation, and I'll find the points. Okay, x plus 2y is equal to 40. So I've written both of them in the form of an equations, and I'm now going to find the points. Now for this first one, if I place 0 in place of x, if I put 0, my y will be equal to 50. And in place of y, if I put 0, my x is going to be equal to 25. Similarly, for the second one, if I put x as 0, then my y will turn out to be 20. And if I place 0 in place of y, then my x is going to be 40. So I got the points. Now I'm going to plot the graph. So now since I've got the points, I'm going to plot the graph. So for the first inequality, the points will be 0, 50 and 25, 0. So 0, 50 is over here, and 25, 0 is over here. Okay, so now I'm going to draw a line joining these 2 points. Now as you can see, the line is there, and this line is of the inequality 2x plus y less than equal to 50. Now since there is this symbol equal to also along with this less than, which means that I have to draw a proper straight line instead of dotted lines. Okay, now I'm going to plot the next inequality. The points are 0, 20 and 40, 0. So 0, 20 is over here, and 40, 0 is this one. Okay, so 0, 20 is over here, and 40, 0 is this point. Now when I join these 2 points by a line, I get the line for this inequality x plus 2y, which is less than equal to 40. Now since again there is this equal less than symbol, this equal to symbol along with that less than, which means that I have to draw a proper straight line instead of dotted lines. So now that I have plotted these graphs, now I'm going to check for the feasible region. Now again let me take this point 0, 0 and check for the feasible region. So my first inequality was 2x plus y less than equal to 50. Okay, this line 2x plus y less than equal to 50. I'm going to check for its feasibility with the point 0, 0, which means that I'm going to put this x as 0 and y as 0, and I'm going to check for the feasibility. Now when I put x and y as 0, I get 0 plus 0 less than equal to 50, which means 0 is less than or equal to 50. Now in this case, if you can see, 0 is less than 50, which means that this inequality is true. Now since 0 is less than 50, that means I'm going to shade towards that point 0, 0. Okay, I'm going to shade towards that point 0, 0. Now I'll check for the second inequality. Now the second inequality was x plus 2y less than or equal to 40. Now again I'm going to take this point 0, 0 and check for the feasible region. Now when I put x as 0 and y as 0, I get the answer as 0 is less than or equal to 40. Now in this case also 0 is less than 40, which means that this inequality is true. Okay, so it is true, which means that again I have to shade towards this point 0, 0. Okay, I'm going to shade towards this point 0, 0. Now when I shade these two regions, I get this blue part. Now as you can see, this blue part is our common region, that is our feasible region. So since we found our feasible region, that is our common region, the next step is to find the corner points and then find the value of z. Okay, so now here this blue part is our feasible region. Now if I have to check the corner points, this A is one corner point, C is one corner point, and D is one corner point, that is 0, 20, 25, 0 and 0, 0. These three corner points I can already see from the graph. Now how did I get this fourth corner point, that is B, which is 20, 10? Now for this one you have to solve these two equations. Okay, this equation and this equation, you have to solve them. Okay, because when you plot the graph directly you won't get that point, because sometimes you can even get in fractions. So like here you can directly see it is 20, 10, but sometimes you can it won't be directly visible because it can either be points or it can be in decimals. So for finding this point you have to solve these two equations, because as you can see this point B is actually the intersection of these two lines. Okay, it is the intersection of these two lines, which means that when we solve this equation, 2x plus y is equal to 50 and x plus 2y is equal to 40. When we solve this equation by either elimination or substitution method, we get the value of x as 20 and the value of y as 10. So when we get these two values, it means that the intersection point of these two lines is 20, 10. Okay, that is how we got the value of B. So this 4 points are our corner points, and now we are going to find the value of z. So these were my corner points, and now I have to find the value of z. Now our z was x plus y. Okay, you can see here our z was maximize z, which is equal to x plus y. So when I find the value of z, now here this is 0, so 0 plus 0 is 0, then 0 plus 20 is 30, then 20 plus 10 is 30. Okay, this is 20, then 25 plus 0 is 25. Okay, so now these are my value of z. Now in the question they had asked us, to maximize z. Okay, we were supposed to maximize z, in the sense we have to find the maximum value of z. Now from these values, if you check which is the maximum value of z, 30 here is the maximum value of z. So with this we have found our answer, that is, so 30 is our maximum value, which means that the maximum number of cakes, okay, maximum number of cakes that are going to be made will be 30, and in that maximum number of cakes, the number of cakes of first kind, as we know that the number of cakes of first kind were x, so here z is maximum at the point 20, 10, and the maximum value is 30. So maximum value is 30, which means that the maximum number of cakes is 30, and it is maximum at the points 20, 10. So here x is 20 and y is 10. So number of cakes of first kind was x, that will be equal to 20, and the number of cakes of second kind, okay, number of cakes of second kind, we took them as y, and the y here is 10. Okay, so with this we found the answer of this question, that is our maximum number of cakes is 30, and the total number of cakes of first kind is 20, and the total number of cakes of second kind that will be formed is 10. So with this our question is over. So with this we have completed our chapter linear programming, and I hope you understood all the concepts that are explained in the video. And if you still have any doubts, you can let me know in the comment section below. So thank you for watching, and meet you in my next video.